Hi guys, your Friendtor Gopika is here, and in this video I'll be discussing the practice set 1.4. Okay, so the first three problems we already discussed in the previous video after the theorem, which was very simple, and let's discuss the rest problems. Okay, so this is the question number 4. So first three we already discussed, as I said. So let's move on to question number 4. Let's read the question. So first let me choose the pointer. Alright, so this is the first question, or this is the fourth question rather. Triangle LMN is similar to triangle PQR. Okay, 9 into area of triangle PQR is equal to 16 into area of triangle LMN. Okay, if QR is 20, then find MN. Alright, so here just remember that this exercise is throughout we are going to use the theorem that we learned in the previous video, okay, regarding the ratio of areas of two similar triangles. So 9 into A of triangle PQR is equal to 16 into area of triangle LMN. Okay, now if I take area of triangle PQR towards this side and 16 towards the other side, then area of triangle LMN upon area of triangle PQR is equal to 9 upon 16. Okay, so 16 went here, and this is taken to the other side, so both of them will go to the denominator. So area of triangle LMN upon area of triangle PQR is same as 9 upon 16. Now 9 I write it as 3 square and 16 I write it as 4 square, and just mark this point as 1. Okay, now why I wrote as 3 square and 4 square? Because we will need it later. Okay, because we know that area of the ratios of area of the similar triangles are same as the squares of the ratio of the corresponding sides. So that's why I wrote it in square form. So also we know that these two triangles are similar. Okay, so using the fact and applying the theorem, area of triangle LMN upon area of triangle PQR is same as MN square upon QR square. Okay, now why I choose this particular sides? Because here QR is given and I need to find MN. So that pair only I have chosen and applied the theorem. Okay, they are the corresponding sides also. So MN square upon QR square. Now from 1 and 2, what do we know? The left hand side is same, so the right hand side also will be same. So we can write MN square upon QR square is same as 3 square upon 4 square. Okay, that means MN upon QR is same as 3 upon 4. Correct? Because taking square root on both the sides, all the squares will get cancelled, and only MN upon QR is same as 3 by 4. Now we can substitute the value of QR and find MN. Simple. So in place of QR I can write 20. Now MN will be 3 by 4 into 20. So 20 I can divide by 4. So 4 ones are and 4 5s are. So what will remain? 3 into 5. 3 5s are 15. So when QR is 20, MN will be 15. Simple. Just applying the theorem. Okay, and this you can easily make out which corresponding sides we have to choose. Depending on which side we have to find, same corresponding sides you choose here for the ratios. Okay, and then match the values. Okay, simple. So you can take your own time, you can pause the video and go through the solution once. If you have any doubt, please write in the comment section. I will reply as soon as possible. Okay, so this is the fifth question. Areas of two similar triangles are 225 square centimeter and 81 square centimeter. That means the bigger triangle has 225 as area and the smaller triangle has 81 as area. Now if a side of the smaller triangle is 12 centimeter, then we have to find the corresponding side, its corresponding side in the bigger triangle. Okay, so first I will name the triangles. Let bigger triangle be T1 and let smaller triangle be T2. Okay, just for convenience I have named them. Okay, now area of T1 upon area of T2 is same as the area of bigger triangle is 225 and the area of smaller triangle is 81. So 225 upon 81. Okay, always a bigger triangle will have larger area. Okay, so this is understood. Now if I divide by 9 the numerator and the denominator, I will arrive at 25 upon 9, because 9 into 25 is 225 and 9 9s are 81. So dividing by 9 we will get 25 upon 9. Now this is the reduced form. Okay, so mark this equation as 1. Now we also know that these triangles T1 and T2 are similar. That is, T1 is similar to T2. One side of T2 is 12 centimeter. This is also given in the question. Let its corresponding side in T1 be x centimeter. Okay, this is what we have to find. T2, one side is 12 centimeter. We need to find its corresponding side in T1, that is the bigger triangle. So let it be x centimeters. Okay, now by the theorem, area of T1 upon area of T2 is same as x square upon 12 square. Okay, because ratio of the corresponding sides is x upon 12, and if you square it you get the ratio of the areas, correct? So this will be x square upon 12 square. Now we will name this equation as 2. Okay, now from 1 and 2 what do we know? X square, the LHS is same, so the RHS also will match. That means x square upon 12 square is same as from 1 25 upon 9. Okay, so this is from 1 and 2. Since in both the equations LHS is area of T1 upon area of T2, the RHS values also should match. That is x square upon 12 square is same as 25 upon 9. Okay, therefore x square is equal to 25 upon 9. This 12 square is 144, and this 144 will go to the other side and it will get multiplied. So 25 upon 9 into 144. Okay, now again I can divide 144 by 9, and that I will 25 into 16, because 9 into 16 is 144. So 25 into 16 is same as 400. Okay, so x square is same as 400. That means x square is same as 20 square, because 400 is 20 square. Now if x square is 20 square, then x is 20. X is 20 centimeters. Okay, because everywhere we are dealing with square centimeter or centimeter. Okay, when the dimension is in centimeters, the area will be in square centimeter. Correct? So again, when the area is in square centimeter, the dimension will be in centimeters. Okay, x is 20 centimeter. So let's move on to the next question. Okay, so this is the 6th question. Triangle ABC and triangle DEF are equilateral triangles. Okay, equilateral means all 3 sides are of same measure. Is that so? What is meant by equilateral triangles? All 3 sides have same measure, and what rest? One more point, all their angles are 60-degree angles. Okay, correct? Yeah, if two pair of sides are equal, then we say it is isosceles. If all 3 sides are equal, then we say it is an equilateral triangle. And one more observation is, all the 3 angles of that triangle is 60-degree. Okay, now if triangle area of triangle ABC upon area of triangle DEF is equal to 1 by 2 and AB is 24, find DE. Okay, now to apply the statement of the theorem, we need 2 triangles to be similar. Okay, so if you observe, 2 equilateral triangles are of same shape, that means they are similar. So by which test we can say they are similar? All 3 angles of equilateral triangles are 60-degree in measure. So if you say in ABC, angle A is 60, angle B is 60, angle C is 60. Similarly, angle D is 60, angle E is 60-degree, and angle F is also 60-degree. Therefore, by all the angles match actually. Okay, not only the corresponding angles, all the angles are matching. So we can choose any corresponding angles and say that angle A is equal to angle D, angle B is equal to angle E, angle C is equal to angle F. And hence by AAA test of similarity, these 2 triangles are similar. Okay, so once they are similar, we can apply the theorem. So area of triangle ABC upon area of triangle DEF is same as the ratio of the squares of the corresponding sides, that is AB square upon DE square. Okay, now what this side, the LHS part is given in the question as 1 by 2. So replace it by 1 by 2. 1 by 2 is equal to AB square upon DE square. Therefore 1 by 2 is equal to AB is 4. So 4 square upon DE square. Correct? Now DE square will go to the other side. 2 will go here. So this will be DE square into 1 is equal to 2 into 4 square. Now DE square into 1 is same as DE square. So DE square is equal to 2 into 4 square. That means DE is same as, now applying square root on both the sides, DE square will become DE is equal to square root of 2 into 4 into 4. Okay, so when within the roots, the factors, when there are when it is repeated twice, the factor will come out. If it is ones, it will remain within the root, correct? So this will be 4 root 2. So 4, there the power of 4 is 2, so 4 came out. Here the power of 2 is just 1, so it will remain within the square root. Okay, so that is 4 root 2. Therefore DE is 4 root 2. Okay, simple. This calculation you have already learned how to find a square root and all, so those are actually simple ones. Just the observation that if you have two equilateral triangles, one thing is all their sides are equal. So if you find AB upon DE and BC upon EF or AC upon DF, you will get same ratios. Okay, and otherwise also all their angles, corresponding angles will match because all their angles are 60 degree. So the corresponding angles has to be equal. Okay, so simple. So that is the observation that we need to write and we need to notice in order to apply the theorem that we learned. Okay, so let's see the last question in this exercise. Now here this 7th question is just like an activity. They have given the framework of the proof or the question. We just need to fill the blanks. Okay, so let's read the question. Now in figure 1.66, segment PQ is parallel to DE. So if you observe, this PQ is parallel to DE. Area of triangle PQF is 20 units. Okay, now this triangle, this smaller triangle, the area is 20 units. PF is 2 times DP. PF is twice DP. Okay, if DP is 1 centimeter, then PF is 2 centimeters. That is what we meant by saying this. Okay, PF is double the length of DP. Then find the area of quadrilateral DPQE. So this trapezium, we can say this quadrilateral's area we have to find. That is the shaded parts area we have to find by completing the following activity. So how the framework would be, now we need to find the area of the shaded part, correct, shaded region, and we know the area of this smaller triangle. So our aim will be to find the area of this bigger triangle, that is FDE. If you find the area of this triangle FDE, from that if you subtract the area of this smaller triangle, then we will get the area of this shaded region. Okay, so that is where we have to arrive. So how we find the area of this bigger triangle? Let's see. So for that we will need the fact that this triangle FDE is similar to triangle FPQ. Once they are similar, then we will use the theorem that we learned and then we will arrive at the answer. So let's start. First, area of triangle PQF is 20 units. PF is 2 DP. This is also given. Let us assume DP is X. Okay, if DP is X centimeters or X units, then what will be PF? PF will be 2X because it is twice the length of DP. So if this is X, then PF is 2X. Okay. Now, if DP is X and PF is 2X, what is DF? DF will be X plus 2X. Correct? DF will be DP plus PF. Correct? And what is DP? X. And what is PF? 2X. So X plus X, 2X is 3X. So DF is 3X. Okay. Now consider the triangle FDE and triangle FPQ. FD is the bigger triangle and FPQ is this smaller triangle. Okay. In that you can note that triangle, or in the triangle we can see two sets of corresponding angles, that is angle FPQ is equal to angle FDE. Okay, so here if you observe, angle FDE is congruent to which angle? The reason is corresponding angle. So which angle it will be equal to FDE? The corresponding angle is FPQ. In the sense PQ is parallel to DE, we are getting this corresponding angles. Okay, not in the context of similarity, but in the context of parallel lines, to angle FDE the corresponding angle is FPQ. Okay, so here we'll get FPQ. Now for triangle angle FED, now if you see angle FED in the context of parallel lines, DE is parallel to PQ, which angle is corresponding to angle E? Angle Q is corresponding to angle E. So angle FED is equal or congruent to the angle FQP. Okay, so these two, the reason is they are corresponding angles since PQ is parallel to DE. Okay, Okay, so by these 2 points, by AA test we can make out that triangle FDE is similar to triangle FPQ by AA test. Okay, so once we got that the smaller triangle is similar to the larger triangle, now we can use that to find the area of the larger triangle, okay, by applying the theorem. So let's do that. Therefore, area of triangle FDE upon area of triangle FPQ will be DF square, that is the corresponding side, and for FPQ the corresponding side will be PF square. Okay, so that will be DF square upon PF square. Now what is DF? That we already found in the beginning, that was 3x. So 3x square upon 2x square, and 3x square will be 9 upon 2x square will be 4. Now this x square and x square will get cancelled, only 9 by 4 will remain. So once we know the ratio of the areas of the triangles, now we can apply the value of triangle FPQ and then find the area of triangle FDE. Okay, so area of triangle FDE is equal to 9 upon 4 into area of triangle FPQ. Okay, now this from the denominator it went to the other side and it got multiplied. So that is same as 9 upon 4 into what is area of triangle FPQ? It is 20 units. So 9 by 4 into 20. Okay, now divide 20 by 4 and what you will get? 9 into 5. 9 5s are 45. So now we easily got the area of the triangle FDE using the statement of the theorem that we learned. Okay, now simple. Now the area of the quadrilateral or the area of the shaded part will be area of the bigger triangle, that is FDE, minus area of triangle FPQ, and that will be 45 minus 20. What is 45 minus 20? It would be 25. So area of this shaded part is 25 units. Okay, so this was the last problem in the exercise or the practice at 1.4, and it is a bit tricky and it has few steps to be followed, but just it's as it is like an activity, they can also ask it as a problem. Okay, so you need to practice this, and if they have not given it like here, it was like the blanks, but it's not necessary that always it will be like this. You might get a problems where it won't be in fill up form, so you should be able to make out the steps. Okay, so practice well and go through the solution. If you have any doubts, please write in the comment section so that we can help you out as soon as possible. Guys, and if you like the video, please share it with your friends and please subscribe the Friendtor channel. You can also follow us on Instagram and DM us any queries regarding the mathematics, and we will respond as soon as possible. Thank you.